Hello, welcome back to section 2.5, Solving Applications Involving Proportions. In this little video, we're going to take a look at another example. So what I've done here is I have given you the same steps that we talked about in example 1, just as a reminder. Again, we want to represent the unknown quantity with a variable, use the given information to set up a known ratio on the left side of the equation, set up the other ratio using the variable and the other given quantity on the right side of the equation in the same position, very important. Solve the resulting equation, which is a proportion, by cross multiplying, and then be sure to answer the question being asked. So I've kept these steps here for us to be able to refer back to if needed. So here again is another example. A vial of insulin marked U40 has 40 units of insulin per cubic centimeter, when we can write that as cc, of fluid. How much insulin should a patient be given if she needs 12 units of U40? So again, what is the question that's being asked here? That's always the first thing we want to look at because that will help us to represent our variable. So the question here is, how much insulin should be given? So how much insulin? Okay, well, insulin is given in terms of cubic centimeters of fluid. And so we need to kind of look back at that first statement maybe to actually figure out what my label might be. As in the last example, I want to be sure to identify that when I identify my variable. So my first step here is going to be to say that I would like my x to be the cc's, because that will be the label that I use, of insulin. And the insulin is really the fluid that's being given the patient. Okay, so there is my variable. So now let's look back and see, well, what is the information that is given? Well, I know I have 40 units of insulin per cubic centimeter of fluid. So if I look at this information right here, and it does happen to go across two lines there, that's giving me my known ratio. This one's a little bit different than the last one because you might notice there seems to only be one number that's being represented in that particular statement I've just drawn a box around. But if I look at it carefully, I'm actually looking at 40 units per every centimeter or cubic centimeter of fluid, so for every cc. So in many proportions you will find that you will sometimes end up needing to use a 1, that it gets simplified, or you start out with something related to 1 of something else. So in the top I'm looking at the units, and on the bottom, I'm looking at the cc. So again, 40 is the units of insulin, and the bottom is the actual amount of fluid. So again, I like to put those units off to the side to highlight that. And it is going to be a proportion, so it has an equal sign in it. Again, a proportion is an equation. So now I need to look at, okay, how do I set up that equation on the right-hand side? Well, I want to know how much insulin should a patient be given if she needs 12 units of U40. So the other piece I'm given is 12 units. Does that go on the top or does that go on the bottom? Well, if we look at the first one, notice that units was on top. So therefore, in the second ratio, units must also go on top. And again, X represents the cc's of insulin, so X goes on the bottom where the cc's or cubic centimeters are located. So once again, I have my proportion. Now I can solve by cross multiplying. So again, I want to start with the cross that's going to involve the variables. So I'm going to start with the 40 times x, and that's going to give me 40x is equal to, and my other cross is going to give me 1 times 12. So 40x is equal to 1 times 12, which is 12. If I finish solving, I need to divide by 40 on both sides, and x is going to equal 0.3. If I write that as a decimal, that is an exact value, and typically with this kind of a problem we will write it as a decimal. And so I have found my x value, but now I want to make sure I answer the question. It says how much insulin? So what I'm looking at here is I'm looking at 0.3 cc's of insulin. Now, this particular problem is a little bit unique in that it's also giving us some specifics about the kind of insulin that's being used. So if you were going to write this on the patient's chart, you might also want to be more precise in saying that it's 0.3 cc's of U40 insulin, since there are different types. And so this might be a more complete way of answering this particular question. So now I'd like you to go to your homework assignment and see if you can set up some proportions from the problems that are given there and solve them as I've done in these previous two examples.